All right, Professor Cooper again. Let's pick up where we left off. This is the second video in the data visualization gganimate videos. All right, so I'm going to pick up right where I left off, and I'm going to show another animation. This time we're going to use the transition reveal function from gganimate. And what it's going to do is it's going to allow time points to unfold in sequence, and it will reveal them as they come up in the sequence. Okay, and so in this case, what I'm actually going to do is I'm going to pick a country and a year. I'm going to do a quick group by summarize because if you remember, if you've been working with the WID dataset, that there might be multiple observations per year per country, so we want to average over those. And then I'm going to have X be the year, Y be this new mean Gini, and then I've added a color for year. And then I'm going to use two geoms. So we're going to draw a line and a point. The point's going to come up at the end of the line. All right. And I've got a little label here for fill-in's income inequality. And then the transition, of course, this is where the animate really comes in. And the key aesthetic here is the key function here, the key argument, I should say. My apologies. A long equals year. And so we're going to run it, and we're going to see what happens. So revealing things over time is one of the best ways to use gganimate and animated plots in general. So there's a transition time, and there's a transition reveal, and then there are even others that we haven't discussed, but these are two of the key ones that you would be using. Transition time is more of a discrete revelation, while transition reveal allows something more like this, which is kind of nice. It's basically drawing a line. It's got the point at the end. And while the color aesthetic here isn't super necessary, it does also highlight that it's getting lighter as you go to the right. It's not terrible in terms of adding that second aesthetic for the same thing, although some people would say don't add a second aesthetic for the same variable in a visualization. That's generally true, but I think there are exceptions to the rule if you're highlighting. Okay, let's move on to the next one. I'm going to do a transition. I'm going to do a little lesson on what not to do, you might say, because let's say that we just wanted to show some points, and I'm going to kill this for a second. And I wanted to show Southern European countries. I wanted to show the year and their scatter plots. So after 1940, we're not going to do by time in this case. We're just going to have all the points. We're going to flatten time. And, I mean, you'll see it, but it's not going to animate over time, is what I should say. But we're going to add an easing, and you're going to see what it's going to do, and then I'm going to talk about why it's not always the best case, or really you should never do what I'm doing with this particular gganimate. It has to do with essentially connecting observations that don't belong together. Because what it's going to do is it's going to create an easing between different countries, which really isn't the best idea. So you see, it's very fast, obviously. We don't have any labels yet or anything like that. But what it's doing is it's easing from country to country. And some of them have more observations and some have fewer. You can see that. But ultimately, this is not the best idea because by implication, because you're using these easings, you're saying that they're connected. Now, with appropriate labeling, you could, in theory, get over that, and most people wouldn't really care one way or the other. But there is an implicit connection when you apply the easing like this. Okay, so we're going to cut that, and instead, we're going to add a grouping variable, and I've still got the easing in, but as it turns out, it's not going to matter. It's going to, it's taking its sweet time doing this one. I'm not really sure what the holdup is. But what it's going to do is that grouping variable is actually going to render the easing moot. And it's going to, well, it'll have a giant legend that we would normally want to suppress in this case, because if you're animating over different countries' observations, as long as you add like a title that also animates and tells you what country you're looking at, then you don't really need the legend anymore. The legend is superfluous. So, plus the legend would be enormous for Southern Europe in this case, because there are a number of countries that technically belong there. So as soon as this thing renders, you're going to see a large legend to the right, and then it's going to rotate through the points, but without that transition that's connecting the points. But we've got a title as well now. So actually what we would do is we would go back and we would do a theme, legend position equals none, get rid of it, and call it a day, fix up our labels and all those kinds of things. But and also slow it down, obviously. But that's easily done. The best way to control that is through the animate function, where we actually save this as an object, and then we feed it into the animate function afterwards, and then we save as anim_save is how we would do that. Like so. So we're going to do that real fast, and then we're going to animate, and you're going to see that it's going to slow it down, and it's going to think. As it thinks, I'm going to set you up for the next, so you can see I've saved it as an object, and then we have the animate function instead. This is another way to do this. And the duration allows us to set how much time, how many seconds, and how many frames per second we would like for each country in this case, because that is the grouping or /state variable. Next, I'm going to show you something slightly different. I'm going to show you how to animate a rose plot, which is kind of interesting. It obviously matches some of the geoms that we've done before. I wanted to show you things that weren't just line plots and points. You can do all sorts of things with this. Almost any geom can be also animated. I would imagine even it's probably true that every geom can be animated, although some will be more difficult than others, given the aesthetics that you're working with. Okay, so you can see what's happening here. All right, that's good. So we'd still fix the labels, we'd still kill the legend, we'd do all those things, but it's slowed down nicely. And then we could take this and we could save it. We could go anim save. Oop. You must spell correctly in order for it to work. And then we could call it wid1 anim dot give. And then that would call it a day. And it will save my project folder as teaching data visualization. So that's where it would go. Cool. Okay, moving on. Now let's try something a little bit different, a different kind of geom. Let's do a rows plot, and I'm going to actually change the data as well. I'm going to go with one of the other data sets that exists in R called diamonds. We've worked with this a couple of times in examples. It's got color, cut, clarity, price, depth, and some metrics, X, Y, and Z. And I'm going to talk through some of the things I'm doing here. So I'm going to group by cut and color to get the average caret size, given the cut and given the color. Color is an ordinal variable, so best to worst. And then, let's see, cut is also an ordinal variable. So we've got two ordinal variables that were ordinal factor variables that were ordered factors, we'll say. And then we're going to summarize and call it average caret. So we're going to get the average caret size given the cut and the color of a diamond. And then we are going to turn this into a rows plot. Theta has to be x for it to be a rows plot. And the width needs to be a constant, because each petal of the rows in this case is going to be the same size. We're just talking about different categories as the angle of the x. And then I put some labels on it. And then this is just, right now this is just the static plot. Let's see, plot 1, if I go plot 1, well, it's not showing up right now. Okay, let's go ahead and make the transition happen. Let's see if the viewer is actually going to happen. I think it is. The bandwidth for the internet must be pretty tied up right now, but this should happen pretty quickly. So we're going to do a quick little rows plot, and this should show petal by petal what's happening with the rows plot in terms of cut, color, and the average caret size. In just a minute. So you see it's unfolding petal by petal. They're similar, they just get larger in size because they go from best to worst in terms of the colors. Colors are categorical, but they start with D and they end with J. Do not know why that is. Don't care too much. That's nice, but I think we'd rather have the petals reveal and stay. Well, we can do that. So we can use something called transition manual instead of transition states. It allows us to work with this, and then this cumulative equals true is going to give us the ability to reveal and show the petals at the same time. Now that's much nicer. And we can obviously use the things that we learned before and adjust the time with the duration and the frames per second and all this. We would also potentially fix some other things, but largely it's where it is. And again, just because it's a little bit fuzzy in the viewer is not a big deal, because that's not how you would see it anyway. If you see it in HTML, which is where it would go to the internet. If you put this on a markdown file, for example, and rendered it in HTML, you would see it clear as a bell. All right, lastly, let us talk about the usefulness, the utility of the transition filter. This allows us to highlight some a variation in a different way than you would if you just had two or three variables, let's say at x and y axis, and then a third as a categorical variable to split up by, say, color, right? So we're going to go back to the MT cars data set because it's useful for this particular example. I'm making, this is something I've done in repeated videos before. I'm going to make a cylinder factor for the number of cylinders in the engine. I suppose we could quickly glimpse the data just to see it again. Okay, so MPG is fuel efficiency, miles per gallon. Cylinders is number of cylinders in the engine, displacement, horsepower, etc., etc. We want weight and we want fuel efficiency, and in this case we're going to take cylinders and turn it into a factor because in the native R data set it's in a numeric, which is nonsensical here. Okay, so let's look at the base plot that we would make if we just made a G on point, just a scatter plot with an X and a Y and a third variable to separate by color, and we've done some changes to the size. Something is going on with my base plotting. Okay, it's just a basic scatter plot and it's static. Okay, I don't know what's going on with my plotting window right now, but the animated plot window is still working, so we're going to go with it. So now I'm going to do the animated version. So I'm going to use transition filter this time. Transition filter is a little bit different. And here's what it lets you do. It lets you do almost like a case when where you have multiple conditions that you can, logical conditions that you can use to simultaneously recode a variable. Well, this is basically recoding how you reveal the data. It's not just necessarily by a variable, it can be by conditions that are applied to multiple variables. In this case, I'm going to apply that condition to a single variable, but in a way that highlights the variation a little bit differently. So the base plot would be the same, but I'm going to chop up the weight variable into small, medium, and large, sort of light and medium and heavy weighted vehicles. All right, and then I'm going to adjust the labels and the titles accordingly, and I'm going to apply this transition filter, and this is where the new coding comes in. So we have a length and a transition. We have a light, medium, and heavy that I'm defining these. Weight is 2.5. So weight is in thousands of pounds. So this is less than 2,500. This is between 2,500 and 3,500, and this is greater than 3,500. And I've identified them as light, medium, and heavy. And then this final argument says keep equals true means I'm going to keep the points that were revealed, like when I revealed the light data, and I don't wipe them away. I don't make them exit and shrink completely, I should say. I'm actually going to have them highlighted, and then they're going to mostly disappear, but they're going to stay so that you can see the full distribution, but the emphasis changes. That's really what this is about. This is about emphasis. The emphasis changes from one of the categories to the next. So we have a weight variable on the x-axis, we have fuel efficiency on the y-axis, and we have the number of cylinders as the third variable, the grouping color variable. But I'm taking the continuous variable on the x-axis and I'm going to reveal it based on levels of that variable this time. And it's going to help us understand the relationship between all three variables better. And then I add an exit recolor and a shrink, and you'll see what this does. What it's going to do is it's going to take the points that were revealed first, and then when they start to go away, they're going to stay behind in gray, and they're going to shrink in size, but they're not going to go away completely. And then I've added some of my own colors here. So let's just run this, and then let's run this, and this will take just a second. So I hope we can talk a little bit about more about all the things that are going on here. You can see each time that we add titles, we can have titles that animate and change along with the variation in the data that's showing up in the plot. But these curly braces represent those animations, right? These change according to what kind of transition you're using. So from closest filter, if I'm doing a transition states instead, it's going to be a closest state or previous state or a next state, depending on which one you want. Just keep that in mind as you see this code. Okay, you can see what's happening here. Like, it's a basic scatter plot, but you're highlighting the variation in a very different way. The lightweight vehicles are all the same, have all the same kinds of engines, all 4 cylinders. The very heaviest have all the same kinds of engines, 8-cylinder engines. The middleweight class have 4-cylinder engines, 6-cylinder engines, and 8-cylinder engines. But you see the variation in terms of fuel efficiency is very consistent. It's almost a perfectly linearly decreasing trend, right? So what that means is the relationship between the number of cylinders in the engine and the fuel efficiency may not be the thing. It may all be about the weight. And it just happens to be the case that the medium weight engines are also, or the heavyweight engines are also 8-cylinder engines, and the lightweight cars also have 4-cylinder engines, right? Now, but there is a relationship, but this sort of adds a level of complexity to it. And it's a nice way to change it up and animate it in a slightly different way. You speed this up maybe just a little bit. You might clean up the subtitle just a little bit. You might change the colors just a little bit. You know, get a little picky about those kinds of things if you want to, and then put this out in the web, put this in, HTML, and it'll look really great. And you might even honestly, you'd move the legend inside to the plotting environment as well, something like that. And then it'd be a really good graphic that could highlight whatever the story is you're trying to tell about these cars really well. Okay, so that's enough for video 2. Take care. See you on the next video.